Good morning, dear students. Today we'll start the next topic, that is the most important entity in operating system, that is a process. We all know that there are two main entities in operating system. One is a process and the another one is a file. Now what is meant by the process? Process means the task the user is executing. Suppose the user is typing from the keyboard, then typing is the task. If the user is taking a printing, then printing is the task. If the user is executing the program, then execution is the task. So we call all these as the program which is under execution. It's called a process. Now, related to the process, the information related to the process, the data related to the process, that information is stored in a file. For example, that if you have to write a program, a C program for the sorting of the 10 numbers, then you will write the program code, okay, and after that you save it. So while saving, the operating system asks you the name of that program. That is, you give the name of the file with the extension. And what is the use of the extension? The use of the extension is to distinguish the different types of the files. So you give a particular path on the hard disk, and in a particular directory the file is stored with the extension just like sort.c. So sort.c is what? It is a file. Now whenever we need to execute that file, then it, it will not execute from the secondary memory. It should be loaded into the primary memory, that is a RAM. When it is loaded in a primary memory, then only it will be given to the CPU for the execution and it will be executed. It means when it is executing, we call it as an active entity. So now it no more remains a program, it becomes a process. Now got it? So process means what? Currently what you are doing. Suppose you are watching the video. So watching of the video, it means your CPU, your brain is totally focused on the video. It means that watching is the task which is allocated to your brain. So it becomes a process. Now let us start with the process concept. Now here we'll consider some terms, some points to be covered in a process related. First is the process concept, then how the process is executed, that is the process scheduling, then the operations on the process, then when two or more process wants to share the information, they must have the cooperation in between, that is called a cooperating process. Then there must be some type of communication between them. We call it as an inter-process communication. So we'll look these points in this particular lecture as per the time permits. Okay. Now process concept just already told you that an operating system executes a variety of the programs. Various types of programs are there. That programs may be a user program or it may be a kernel program. Kernel means the operating system part. Okay. Now that may be that operating system task may be named by different terms. That is, if it is working in a batch system, that is the group of the program, we call it as a job. Okay, so the collection of the job forms a batch. The collection of similar type of task or similar types of jobs call it as a batches. So in some operating system, a single job is not executed, a batch is executed. That is, the similar 10 jobs are there, then the similar 10 jobs will be given to the CPU for the execution. So execution is in terms of the batches. So it is called it is batch system. In certain system, Every job or every task or every user program is allocated some fixed amount of time. Let's call it as a time slice or the time quantum, so that it should be a means equal opportunity should be given to the each and every program. Every program is given the fixed time. So the complete time of the system is shared among the multiple programs or the jobs. Time shared system. Okay. So variety of programs are there, just I told you. Now what is the process? Process means what? A program in execution. Okay, the program which is currently executing. Suppose you have noted multiple things or multiple notings on your notepad. But if you are executing a particular thing currently, then it becomes a process. Otherwise, it is a part of the notebook, that is a secondary memory. Okay, so process execution must progress in a sequential manner, that is one instruction at a time. Now, what the process includes, what the process consists of. First is what? It is a program counter, because process consists of what? Sequence of instruction. Then there must be someone who points after the first execution for after the first execution of the first instruction, then the pointer should move to the second instruction. Then after the execution of the second instruction, the pointer should move to the third instruction and so on. So who does this? Who keep track of the address of the next instruction? So there is a dedicated register called program counter. So process must contain a program counter which points to the next instruction, next instruction, next instruction, so that the process execution will be proceed in a sequential manner. So program counter. Then second one is a stack. Now what is the use of the stack? Stack is used generally for the execution of the functions, because a program consists of set of functions. Sometimes it may contain one function, sometimes it may contain two functions and so on. So program consists of a set of functions. So for the execution of a particular function, a stack is needed. So stack is what? It is a temporary data structure which holds, when the function is called, the data will be loaded in a stack. When the function is executed completely, data will be pop up from the stack. So stack is just a temporary memory. So stack should be there. Then the data section should be there. Data section means what? The data on which the program will execute it. Consider the example of sorting of 10 numbers. If we execute that program, then the data we require is that is the data on which the sorting to be applied. That is data section should be there. Okay, and another one is a code section should also be there. Now this is about the that is a process. It's a basic idea behind the process. Now what are the different states of the process? In which states the process are? So what happens generally? See that whenever any new idea arise in your mind or keep that is enter in your mind, then that we call it as a new state. Okay, so as far as the process has been execution, it goes on changing the states. So when the new process is created, someone wants to write a new program, then its state will be a new state. Then the second is that a running state, then waiting state, then the ready state, and the terminated state. For the time being, just keep it as it is in mind. With the diagrammatic representation in the next slide, I will explain in detail. See, this is the diagrammatic representation of process states and how process changes the state from one to another. See, this is a new state. A new program has been arrived in a memory. So it is in a new state, okay? Now, when this new program wants to execute on the CPU, CPU means it will go in a running state. Then all these programs are kept in one queue, called it as a ready queue. So its state becomes ready state, means the process is ready to execute. Got it? So new, then this new program will be admitted by the swapper into the main memory, but it is ready for the execution. So it will be in a ready state. Then the scheduler will select one of the process from the ready queue and hand over to the CPU. When it is executing, it will be in a running state. Okay. Now while the process is running, some interrupt occurs. Then the CPU have to attend the interrupt. In such case, the process will be interrupted and again it will enter in a ready state. Okay, again after some time the CPU has given the services to the, that is the interrupt. The CPU will resume its execution. So from ready it will again go to the running state. After the complete execution of this process, the process may need to perform the I/O operation. So for I/O operation, if the I/O devices are ready, then they will be allocated. But if the I/O devices are busy, then the process have to wait for the I/O devices. See, I/O or event wait. So it will go to the waiting state, means waiting for the I/O devices. When the I/O device becomes free, the process will be allocated the I/O devices and the I/O operation will be completed, and now again it will go to the ready state to execute the that process on the data. Okay, again this will be loop will be executed, and after that it will go to the exit state, that it will be terminated. Got it now? So what are the different states of the process? New, newly created, ready for the execution. Scheduler select the process, go to the running state. After the execution, it needs the I/O operation, that it wants to print something on the printer or it has to take the data from the keyboard. Then it will go to the waiting state. After this I/O operation is completed, it will go to the ready state and so on. And while running, if someone interrupt, then process will be interrupted. So new, ready, running, waiting, and terminated. So what is the difference between ready and waiting? Ready means the process is ready for the execution. It is waiting for the CPU. And waiting means the process is waiting for the I/O devices. These are the different states of the process. Now, what type of information is stored about the process so that the operating system will recognize it as a useful entity? And that information about the process, just like that, if the student is newly admitted in a college, that is in a first year, then the information about the process is the name of the process, then the address of the process, then contact number, then the percentage, and so on. Then only the student will be recognized in a college after admission. Similarly, the process is recognized by storing certain information. That information is stored in a data structure called it as a process control block. So related to every process, there is a process control block. Now let us see which is the information associated with every process is maintained by the operating system. The first and the most important thing, just we have seen that the process goes on changing the states. Process states. Okay. Then the program counter. I just told you that for every process there should be a program counter which points the next instruction. That is, if the first instruction is completely executed, where is the second instruction? So what is the address of the second instruction? So program counter points to the next instruction. It is a special register. Then CPU register, while executing, it needs certain registers to store its temporary data for the calculation. So CPU register. Then CPU scheduling information means how, when the process is kept in a ready queue, how the scheduler select it. That is first in, first out. That is whether it select the first process from the ready queue or whether it select the shortest process from the ready queue, or whether it selects the highest priority process in the ready queue and so on. That is, in which way the process is selected from the ready queue, that we call it as a CPU scheduling information, or how much time it needs to execute on the CPU, that is called it as a CPU burst time. CPU burst time, all this information is maintained here. Then the memory management information, it means where in a particular area the process is stored, which memory area is allocated to the process, that is which is the lower address, which is the higher address, and so on, what is the size of the process, this memory management information. Then accounting information means what is the time, at what time the process enter into the system, how much time it requires for the execution, that is CPU burst time, how much time it has spent in performing the IO operation, that is IO burst time, and so on. All these numerical accounting information should be maintained here. And then IO status information. IO status information means if the process IO operation has been completed or not, or still it is waiting for certain IO devices. So all this information is stored in a block called PCB. Why there is a need of the PCB? Because so that the process should be a recognizable entity. Okay, so process state, program counter, CPU register, CPU scheduling information, memory management information, accounting information, IO status information. Okay, so all this information is kept in a PCB. So this is just the diagrammatic representation of the PCB. This list of open file means how many files the process has worked, how many files the process has opened. So list of open files, and this pointer is a pointer to the PCB of the next process, because there are many processes residing in the main memory. So one PCB, it should point to the second PCB, third PCB, and so on. So who points this? This is a pointer. So pointer means the address of the next PCB. Okay. Now how the CPU switch from process to process? See, here is P0 and this is the P1. When this P0 is executing, this arrow indicates that it is executing. When it is executing, then the operating system is in between what? Operating system has to save the state of this P0 in a data structure called PCB what? 0. Then what happened? During this time when this PCB is active, PCB 0 is active, it is loaded in a memory, then P1 will be idle. Okay. Now what happened? After the complete execution of this P0, who is executing here? P1. So now the operating system has to reload the state from the PCB 1 here. And P1 becomes idle. Sorry, P1 was idle. Now P1 is executing. So PCB 1. And this is idle. And up to this point to this point, this P1 is executing. So PCB 1, if the interrupt occurs, then what? The CPU has to give the service to the other. Again it has to stay after the interrupt has been completely executing. So in this duration the interrupt is executing, then it will save the state in the PCB1, and then when it is idle, then this will be executing. This is just how the CPU switch from one process to the another process. Okay. Now we'll see the process scheduling queues, which are the different queues maintained by the operating system to store the process. First is a job queue. So this job queue contains the set of all the process in the system, including the main memory and the secondary memory. Then ready queue, it stores the set of all the process residing in the main memory only, which are ready for the execution. That is, they are waiting for the execution. And another one is a device queue. Device queue means Whenever the process has to perform the IO operation, then they will also be kept in a queue. That is, two processes are there, they are waiting for the printer. Then that two process will be in the printer queue. That is the set of process waiting for the IO devices. And the process migrate from one queue to the another. Okay, so this is job queue where all the process including the secondary memory and the primary memory are stored. Ready queue, those are ready for the execution, waiting for the execution, and device means those are waiting for the IO devices. And process migrate between one queue to the another queue. So this is all about the process scheduling queue. Okay, so thank you.